And I'm trying to figure out how to make it accessible to people. So talking about stuff seems to be the way to do it. Doesn't matter how old you are or where you are, just thinking about the things that surround us, all the stuff. That all comes from petrochemicals. It didn't used to, but it does now. And so what impact does that have on us, and how is that linked to climate? So, think about the building materials that you're in, the building that you're in, or buildings that you spend time with, things in your kitchen, things that surround the food that you eat, the things that you wear. That's all, a lot of that, the vast majority of it comes from petrochemicals, which come from fossil fuels, and that's the immediate link to climate. So I wanted to give you a tiny bit of background about me, but I won't spend a whole lot of time here, mostly to say I didn't grow up in the US. I grew up in Southeast Asia. I graduated high school at the international school in Bangkok. I came to the US for college. So I went from elephants to snow, which was something of a culture shock. And then when I left graduate school, I chopped up fruit flies as a graduate student and said, I don't want to be in academics. I want to be out in the world doing stuff. And so I ended up as one of the first few women doing a hazmat inspection for the state of California. And in that process said to myself, why are we dumping this stuff out pipes and smokestacks? This makes no sense to me. And found my way into where I am now, which is green chemistry, and thinking about how do we make these materials safer, and then asking the question, do we need this stuff at all? And how do we change stuff so there isn't so much of it? We've had a huge increase in the amount of stuff that we use in the last 40, 60 years, post-World War II. And part of that is because the fossil fuel industry has looked for ways to find other ways of using fossil fuels. And the vast majority of petrochemicals go to things like agriculture, to the packaging that Lena talked about in her intro, and to a little bit to pharmaceuticals and some to industrial manufacturing. So how do we change the system? I've been an independent consultant for almost 20 years now. It's hard for me to believe. And I've worked with just about everyone I can think of to figure out how we do this. So if you're thinking about going into this field, there's a bunch of different ways to do it. Giovanni, you said you're interested in material science. That's actually one piece I haven't tackled, and I would love to do that. I talk to material scientists a lot, and it's really exciting because they're thinking about solutions to some of these challenges. So I've worked with nonprofits, both internationally and locally. Blue Green Alliance is one. It's a group of labor unions, manufacturing unions, and the big greens like Sierra Club. It was started by Sierra Club and the United Steelworkers. And then I've worked in sectors, so the electronics sector. Women's Voices for the Earth works in cleaning products and cosmetics, things that disproportionately impact women. I've worked with government because government has the ability to change what they purchase and change markets. And it also has the ability to educate. Both San Francisco is huge, for example, a city that you all, I assume, live in, or many of you live in. It changes not only its purchasing, but can educate its own businesses and its citizens about toxic materials and safer alternatives. For businesses, I've worked with large businesses like Walmart and Costco, who sell a large number of products in their stores, and therefore can affect a lot of different sectors. And I've also worked with startups, so groups that are just targeting one subset of product and figuring out how to do it better. Cleanwell worked on hand sanitizers long before the pandemic and tried to figure out how we did it without toxic chemicals. So they do it with thyme oil, thyme and rosemary, the herbs. And NewGen Surgical is targeting plastic waste in the emergency room, hospital emergency room. And I also do some work with academics. And I'll talk a little later about one of my most exciting groups, which is the UC Berkeley Center for Green Chemistry that takes graduate students from different areas, chemistry, environmental health, business, architecture even, and pairs them with industry partners to figure out a solution to a hazardous chemical problem. But I wanted to back up and give us a little bit of context. First, let's think about what's the goal we're trying to achieve. This is the way I like to think about it. This is a fairly new idea called donut economics. And the idea is this: inside the donut is what's called the safe and just space for humanity. Right now, the way our economy operates, all the bad stuff, including impacts on the environment and human health, count towards economic growth. So that improves economic growth. And that, to me, and to many of us, doesn't seem like a great way forward. So how do we rethink economics so that we stay, this outer circle is the boundaries of the planet, fresh water, climate change, what you're focused on today, land use, biodiversity, and all these things intersect in different ways. But how do we stay within those limits? And still the inside of the donut still meet the goals, meet the needs of everyone on the planet. including the 1 billion people who live on the planet and live on something less than $1 or $2 US a day. And if you go online, you can find an interactive version of this that talks about where we're already in overshoot. Climate change is finally getting what we need, coverage that we need in the news. So is biodiversity. There's a whole lot of other stuff we need to be talking about, including how we're not meeting everybody's needs. And I've spent most of my career over here in chemical pollution, and the challenge for chemical pollution is that it's really hard to measure. But I can tell you from my work and my colleagues' work here, we are definitely an overshoot in terms of chemical pollution. And it intersects with a whole lot of other stuff. Ocean acidification, plastics go into the ocean, reduces the ability of the ocean to absorb carbon, impacts biodiversity, and so forth. There's another thing that you'll probably hear a lot of, which is this new framing called the circular economy. It's just something you should be aware of. People are starting to use the phrase a lot. And the idea is that we've had this very linear model. We take stuff out of the environment, we make it, and then we waste it. We burn it, we dump it in the landfill, or it goes out into the environment. And the idea of the circular economy is that we split into two things: technical nutrients, so minerals and things like that, and then renewable nutrients, things we can grow, and reuse them. That's what these circles are. This is called the butterfly diagram usually. How many times can we reuse each of those resources before the last thing we possibly do to them is burn them or put them in landfill, which is the thing we don't want to do. So just as a concept that you may be hearing more about. So the biggest takeaway I want you to leave with today is that materials are in fact linked to climate, because most of our materials come from fossil fuels. Is like 99% of our materials come from fossil fuels. If you think about the clothes you wear, just last year, I think polyester exceeded cotton in global fashion of the material that we use. And cotton itself is not huge. I mean, organic cotton is great, but there's not very much of it, and cotton has a huge impact on the environment as well. But most of our stuff comes from petrochemicals, and as we have been more successful in shifting to renewable energy, it's freed up cheap because we subsidize it. Again, back to our economic system, subsidized natural gas, and that goes to petrochemicals. And in fact, petrochemicals and all the stuff that's made from them is going to drive oil demand over the next 10 years, which is a huge challenge for climate. And there's a great petrochemical build out happening now in North America and around the world, but heavily in North America. This map is a map of fossil fuel resources in the US. So right here is Western Pennsylvania, where oil was first found in North America. And the Ohio River Valley comes down this way, and there's still a lot of stuff being pulled out here and a lot of build out. And then it comes down here through the Houston Ship Channel and Louisiana and the Gulf Coast, which is an area known as Cancer Alley for all its petrochemical production over the last 20, 30 years. So this build out, if it succeeds and it's motoring along, will reach approximately 8 times our US greenhouse gas emissions from 2017 by 2030. So in less than 10 years, if we allow it to happen. And all of that is being built to make more plastic, essentially. And in addition to that, it is going to have impacts on communities all along this area and across the entire country, but primarily in this area, who are already exposed to toxic chemicals as a result of manufacturing. So that's the other thing that we need to think about. So back to your donut, how do we meet the needs of everyone within the limits of the planet? In our current economic system, these impacts on humans and the environment are called externalities. And so they're not factored into the cost of the product. And if we did, then we'd have a lot less stuff, and we'd have more durable stuff and a lot less toxic stuff. So that's the goal. So this is just to give you a sense, you probably all know this, but because it happens here in the Bay Area as well, communities of color and poor communities have higher exposure rates to toxic exposures, air pollution, leading to more downstream health issues. Industrial sites, landfills, and so forth are more often located in communities of color. And this is compounded by toxic chemicals in water, if you have water access, and materials in low-income housing, including lead, for example. In addition, poor communities and communities of color are the first to feel climate impacts. So this is what we're calling the intersection of materials, chemicals, climate, production. So that's environmental injustice right there. So now I'm going to go into, actually before I do that, I'm going to stop and see if there are any questions, and then I'm going to go into the kinds of work I've done to give you a taste of the kinds of things that can be done. Again, not comprehensive, but just a clue as to where you might want to work. Any questions so far? Giovanni.
I was going to ask, is this, or is the model that you showed us, the circular model of growth, is that in any way related to degrowth? Or like...
Not as much as I would like, but yes, those are sort of continuing, degrowth is continuing that conversation, yeah. Yeah, thank you for bringing that up. That's key. I think we can't do any of this without reducing consumption and degrowth. So, which means going in the opposite direction, right? Which means actually changing, because everything is driven by our GDP right now, our global, I don't know what it stands for, global domestic product. And what's a different marker that we could use? One of the things my colleagues and I are talking about is, what if we talked about health and well-being? What if we reoriented our entire economy, our government, our structures around everybody's health and well-being, and valued that? Right now, you know, healthcare, which is intervening when we're sick, which we could have prevented. You know, in many cases, we could have prevented some health impacts. That doesn't count towards our GDP. So how do we change that system?
Do you think...
we'll have that fixed by next Tuesday. Yeah.
Do you think that this could be achieved through government regulation or through like the restructure of the global economy? Like, do you think...
I think that's not an either or. I think both have to happen. Yeah, okay. But that's a great question. Glad to hear you're thinking about it. That's awesome.
Thank you.
All righty, so very quick tour on the work I've done so far. Just to give you a sense of where one could work, I started changing local models of economics. And I particularly focused on women, immigrant women, because I grew up in Southeast Asia. A lot of the immigrants that come here are coming from elsewhere in Latin America or in Asia, and they come in. This is where economics interacts with chemical exposure and environment. Is they come in and they take a job that's what's called a low barrier to entry job, easy to get, but it tends to be unregulated, and so you get high chemical exposures that are not. And many of these are workplaces that are not OSHA regulated, so they don't have the same controls that workers in industrial facilities do. And even that in industrial facilities is inadequate protection for most workers, both here and globally. So I started working with a nonprofit 15 years ago now, working with Latina immigrants, and created worker-owned co-ops for when green cleaning was a new thing, greenhouse cleaning, to reduce worker exposure. I also worked with hotel workers who also are heavily Latina, at least inside the room. It's an interesting split. So inside the room tends to be Latina immigrants, and then out in the hallways are African-American men. So different levels of exposure, different genetic background, different other compounding exposures that we have to think about in terms of worker exposure. I've also worked with Women's Voices for the Earth. There are a lot of consumer products that disproportionately impact women. And when you take consumer products that are designed to be safe for short-term use and have nail salon workers, for example, exposed to them 10, 12 hours a day, 7 days a week in order to make a living, they have unintended consequences. So reproductive health hazards, we've had stories of birth defects, and often these populations are not studied. So we've tried to solve some of those problems. I've also built tools to help workers, because workers are required to have information about the chemicals they're exposed to. We designed this online tool so they could type in the chemical, name or number, CAS number, and find out how it was impacting their health immediately, short-term or long-term. This is going to poison me if I swallow it accidentally or breathe it or get it in my eye. And what's a safer alternative that I can talk to my worker about, talk to my employer about. We did something similar for consumers. It was one of the earliest tools where you could take a picture of a barcode of your laundry detergent or your shampoo and figure out what ingredients were in there that were potentially harmful to you, because these are basically unregulated products. People assume that if it's on the shelf, it's regulated. It's not really true, and it's not well regulated. They just have sort of fallen through the cracks. We've made some improvements over the last couple of decades, so it's better. We have a little more transparency on ingredients. And then I do this work internationally as well. There's an international group that has come together to affect international chemicals policy reform, but they also work frontline. So workers in plantation workers in South India that are being exposed to pesticides while harvesting cashews, everything from that front. And then we work on skin whiteners in the Philippines that have mercury in them, a whole bunch of stuff, all these frontline chemical exposures that are linked to this international global chemical economic structure. You could also work with companies, which I have done, both large retailers who are hearing it from, from consumers like us saying we don't want this stuff in our products, and are able to go up their supply chain and talk to. One of my colleagues has had retailers talk to the upstream chemical manufacturers and say, how do we solve this problem? It's a challenge because supply chains are long and the message gets lost on the way. But we are getting there. And then I've also seen small companies that are selling safer products come to me for help as well, saying, can you help us publicize what we're doing? And can you verify that what we're doing is actually better for the environment and for people? One of my favorites is Green Toys in Sausalito, who take recycled milk jugs, the big ones, the HDPE, and turn them into durable toys. So that's solving a bunch of problems. You don't have the single-use plastic, you're not filling more landfill. And my favorite is their recycling truck, which I had for many years, and then I finally donated to the 3-year-old down the street who loves it. So that's reuse right there. We've also worked with the electronics sector. We've worked a little bit with the apparel sector. There's a whole bunch of sectors where we've just tried to move up the supply chain and say, why are you using a hazardous chemical that's impacting the environment and your workers and your end consumer in some cases as well. And the textile and apparel industry has been pretty good. They've taken a huge lead and said, we don't want to be distinguished on the market for having a more or less toxic product. So, and we all use the same supply chain. So let's figure out how we can stop contaminating rivers in Bangladesh, because we all use the same chemicals and the same suppliers, and put a good product out on the market. I mentioned academics early on. I'm on the board of the UC Berkeley Center for Green Chemistry, and we have, as far as I know, the only one in the country, possibly in the world, Greener Solutions graduate class, where we take students from all different expertise. So it's like chemical, environmental health, architecture, business, as I mentioned. And we bring them together and partner them with industry, and industry comes in and says, we have this hazardous chemical, we don't want to use it anymore in our process. Can you help us figure out how to do it? And the really different thing about this approach is we use something called biomimicry or bio-inspired design. Are any of you familiar with biomimicry? You heard about this? This is asking the question, how does nature do it? So if you think about, we've had adhesives, for example. How do you make adhesives work? What are these called? Lizards with they have their little sticky paws. How do they stick on a wall? People have looked at that structure to say, how do we recreate an adhesive that way that's non-toxic? And so you can stick stuff together and you can, remove it, so you don't have to have even more toxic solvents to get the glue off. There's another kind of glue that was used. So most of your furniture is made with medium density fiberboard, MDF, and that uses formaldehyde, which is known human carcinogen, and yet it's still used in millions of metric tons globally and in a couple of different applications. And there was a chemist at Oregon State University who went out to the beach one day. So this is, you need to get out of the lab every now and then is the moral of the story. And he looked at mussel shells that were sticking on the beach, and the waves kept coming. And yet these mussels, every 10 seconds or so, another wave would come and these mussels stuck. And he said, how are they sticking to this rock? So he looked at the structure of that mussel glue and he recreated it from soybeans. And so he had a green chemistry solution. And this is now in Columbia Forest Products, I think was the first company to use it. So if you buy plywood from Columbia Forest Products, it's done without formaldehyde. And that's biomimicry. And my most exciting example recently is Nike came to partner with Greener Solutions. And they had athletic shoes that are made out of polyurethane. Well, all of you have them, I'm sure. And they have to finish it off with a toxic solvent. And so at the end of the semester, the students gave them a whole array of potential substitutes. One was to put a slightly less toxic solvent in. Another option was to change the way they treated the material, so they still got the surface that they were looking for. And the third was to change the material entirely. So it is possible. Unfortunately, right now it's only in like high-end handbags, which is not my favorite thing. But you can make leather out of mushrooms, out of mushroom mycelium. So we're thinking about, so keep an eye out for the shroom shoe coming to you soon from Nike. And many other projects. So if you want to look at Greener Solutions, there's a link in my slides, or I can send you or talk to you more about it. I think I'm talking too long, so I'm going to skip that part. Well, actually, no, I'll go back to this one. So let's go back to petrochemicals for a minute. Where are petrochemicals used? Petrochemicals, it turns out, are used in 5 basic areas: fertilizers and pesticides, so 2 huge places in agriculture; industrial solvents, kind of the materials we've been talking about; pharmaceuticals, I'm not going to touch that one. My husband spent 25 years in that industry and there's a lot of work to be done; and plastics. Plastics is probably the biggest intervention point I can think of. And 40% of plastics go into packaging. Lena talked about that at the beginning. So this is where some colleagues and I are starting to think about, how do you shift the entire system? Why do we wrap food in plastic? Let's back up a bit. So what's the link to climate? Food waste. When you waste food in the field or in, in this picture here, we've got it in a supermarket. A lot of this stuff is not going to get sold. It's going to get wasted and go to landfill and generates methane. Methane is a more potent greenhouse gas than CO2. So that's a link to climate. And we spend a lot of time and energy with fossil fuel-based fertilizers and pesticides to grow that food. And so you've got another whack on the climate right there. And then we wrap it in plastic made from fossil fuels that impact the climate. So how do we solve for what they call a wicked problem, right? This is a really complex intersecting problem. And one of the things we can do is change the system. And we've seen this during the pandemic. We've realized that we need to get food more locally in order to be sustainable and to make sure that everybody in an area has food and has access to food. So what if we don't put it in food packaging and we figure out another way to make just enough food so that we don't have food waste, make people understand that imperfect food is still good, because a lot of the food that's left in the field just isn't that pretty. It's like, get over it. It's good stuff, right? Don't waste it there. So just think about all the places we waste food and fix that system. Another opportunity is, if we still need packaging, make that packaging out of something biologically based. I think the last session I talked about kelp. You can make packaging from seaweed, and in fact, people are doing that. So a lot of the plastic waste and food waste in Asia is these little sachets. So probably the closest thing that we have here is a ketchup packet, but everything's sold in it. Laundry soap, cooking oil, coffee, food is all sold in these little plastic packets, and then that gets thrown. And so now cities in Asia are ankle or knee deep in this stuff. And there's an Indonesian company that's making that same packaging out of seaweed, so it biodegrades. And you could also make it edible. So you can make your packaging edible. So that's going to take me to my next. All the material scientists on the call today will be really excited by this. These are the ideas that really excite me right now, because they're solving a bunch of different problems. So that's what I'm going to leave you with. So over here on the left is the James Dyson Sustainability Award winner from last year. There's a gentleman from the Philippines who created a flexible solar panel that picks up UV even when it's overcast. And he's designed this so that you put it on the sides of buildings and generate energy that way. And he's made it from food waste. So the thing that picks up UV is like the stuff that's left over from turmeric, this thing behind him, behind the solar panel here in this picture. So he's taking food waste and he's turning it into a solar panel that will generate energy. Moving up to this picture of spoons on the top here, this is a company in India that is trying to solve 2 problems, at least 2 problems. One is that the main crop is rice, and when rice is finished growing, they burn it. They burn the stalks that are left, and that causes air pollution and water pollution. And he said, well, and it's also not great for the soil if you use the same crop over and over again. So he's diversifying the crops that are used. Each of these is made from a different kind of grain, millet, rye, I forget what the other ones are. So we're diversifying agriculture, which pulls carbon out of the atmosphere back into the soil. So that solves the climate issue. And each one of these is edible. So when you finish your tea in the morning or your coffee, or you finish eating your rice and curry, you eat your spoon. And not only that, but each one of these spoons fills a nutritional need. So it's solving for malnutrition in India as well. That's what I call a really cool answer to a problem. Down here on the left, I was born in Singapore, so I had to include a Singapore example. And this is Nanyang Technological University in Singapore. And they've taken something called okara, which is the waste that comes from making tofu or soy milk. And it's a high protein, high fiber leftover of the soybean. What happens when you squeeze the soybean? And it has Zippo flavor. Guarantee you no flavor. Tried to cook with it several times and there is nothing there. It makes for really fluffy croquettes or meatballs, but that's about it. Also makes a great chocolate cake if you add enough other stuff to it. So the folks at NTU turned it into a biodegradable plastic film. So here's another thing. If you still want plastic film for packaging to get your food product safely to your customer, it can be biodegradable and it can be made from food waste. So solving climate issues on a bunch of different fronts. Over here, you see, this is probably in Watsonville. So if all of you have gone down to see where our strawberries come from, you're around in California. Strawberry plants, they keep nematodes down with this sheet of PVC plastic. PVC plastic is about the worst possible plastic on the planet because it's toxic from beginning to end, doesn't get recycled. And this is used in this agricultural application. A colleague of mine has a startup where he's using wood waste that comes from wood processing industry, making the equivalent plastic from a bio-based source. So from that wood waste. And when that plastic that he makes out of wood degrades, it actually adds nutrients to the soil. So again, replacing a pesticide that could be made from a fossil fuel, replacing a non-recyclable plastic was also made from a fossil fuel, and actually adds nutrition back to the soil. It's just something else we need to do. That's another day's worth of or more of lectures. We need to take the carbon out of the atmosphere, and we can do it in soil, and we have the technology to do that. It's called a tree or a plant. It's been, evolved over several billion years, and it does it really well. So probably one of the most exciting things that I've seen in the last few years is this technology here. There's a little tiny bridge here with some Erlenmeyer flasks. One of the biggest emitters of greenhouse gas emissions right now that we're trying to deal with is construction. So it's the manufacture and transport of concrete and steel to its location to be built for buildings. So how do we deal with that? This is a little tiny bridge. This is a scale model, obviously, this is made of a bacterium that takes carbon out of the air and mineralizes it, basically turns it into concrete. So how cool is that? You take carbon out of the atmosphere, you eliminate your transportation cost, and you basically grow your concrete on your building site. So we haven't taken this to scale yet. There's a gentleman at the University of Colorado. Anybody who wants to do college or grad school there, I highly recommend this. I can give you all sorts of recommendations to him. That's just a really interesting way of thinking about solving a problem, a climate problem and a material problem. And then finally down here, this is work that I'm working on. This thing here is called a giant reed or Spanish cane. You've seen it. I've apparently seen it for many years and not recognized it. It looks like bamboo and corn had a baby. It has these long fibers, and I'm working with a colleague. This can be turned into all kinds of stuff. It could be turned into packaging. It could be turned into sustainable aviation fuel, so to make flying less climate impactful. And we're also using it to substitute it can substitute for wood in things like MDF, like the stuff that we make furniture out of. And we're working with a large company whose name we can't mention, but you know it well. It has a store in Emeryville, and it sells meatballs and furniture in the same store. And they know that globally they use a large proportion of wood, and that's not sustainable. So they've been looking for other stuff to grow this with. And the cool thing about this grass is that it takes carbon out of the atmosphere and pulls it back into soil, and it can be grown on marginal soil. So one of the issues about growing bio-based materials is that it could compete with food. And this doesn't. This takes land where you can no longer grow food, and it restores it to the capability of growing food. So those are multiple ways that with materials we can solve health problems, here in this case nutrition, transportation, reduce transportation by growing your concrete on site. Over to the left here, using food waste either to make plastic or to make flexible solar panels, make stuff instead of plastic that actually restores nutrition to soil. So that's a very quick tour of the kinds of complex intersecting problems that I like to see and how materials intersect with climate. And so I wanted to pose the question to all of you. What do you see around climate? What kinds of solutions do you want to work on? And who do you think would work in there with you? Communities? I've worked with the nail salon workers, I've worked with companies, I've worked with government, and there's lots of other options as well. All right, I think I did a better job of covering that in a shorter period of time this time, Lena. What do you think? Kind of high speed.
Yeah, that's good.
All righty, so that's yes, Sophie.
Oh, I just had a question about policy and what we as kids can do, and if there's any organizations that we could
Lots of organizations. Yeah. So probably the most successful models that I've seen are nonprofits who are able to organize people just like us, and it doesn't matter how old you are, to say we care about this issue and then translate that into changing policy. It's like we've got, hundreds of thousands of people that have come to us and expressed this problem. So it depends on what you're interested in. So in San Francisco, there's breast cancer prevention funds, does this for a whole lot of stuff. Breast Cancer Prevention Partners. Sorry, they changed their name and I've forgotten. They used to be Breast Cancer Fund. California Healthy Nail Salon Alliance does it for nail products. Women's Voices for the Earth will do it for cleaning products. And then there's all these places like the Electronics Coalition. There's an industry coalition you can write to. You're over here on my screen, so that's why I'm looking that direction. Anyway, depending on what product it is, there's folks out there. So feel free to write to me if you've got a specific challenge. Let me think. The textiles and fast fashion is one that we really need to tackle pretty quickly. And that's, there's a really badly named industry campaign. It's the Zero Discharge of Hazardous Chemicals, or ZDHC. But if you look up, if you just look up fast fashion and sustainability, you'll get there, or you can give me a call. Yeah.
Thank you.
Sure. Questions?
I have a question about degrowth, kind of
Sure.
more economic models.
Yep.
Do you think, I mean, obviously, I think we all in this space want or support degrowth, right? We support more sustainable models of economy, but do you think that governments or would it be like maybe the elite in the world, do you think they'll realize that degrowth is probably the way to go? Do you think they'll realize that GDP is like not
there are governments and think tanks and other folks already talking about how we do that, how we make that transition, and take care of the people. You probably know about just transition. Take care of the people that right now are getting their jobs from like oil and gas workers. How do we make sure that they don't suffer, because their communities will be impacted as well, right? So how do we do it well? So there are discussions happening, and keep in mind that all of us, or people like us, are what put government in place. So we can change it. We can totally change it. So we just keep bringing it up. It's what I'm seeing happen is it's happening at the city level. The city of Amsterdam, for example, is taking donut economics as a model. I've thought about, I actually met with my colleague who runs the San Francisco Department of Environment yesterday. I should have mentioned it to her. San Francisco is a huge lead on this, linking economics and climate, and because of its name, even it's a relatively small city, it meets with other cities that are working on it. So there's lots of space for that conversation to happen. And I think it's ripe. I think the time is ripe to have that conversation. Does that help?
Yeah, I did, or that did help. Thank you for the response.
Sure. And Sophie's back. She's back on screen. Any other questions? Those of you, I can't tell if you're not on screen, I can't tell how you're reacting. So feel free to just pop in and ask a question. What year are you all in school? I know I had some freshmen in my last group. Kylie.
I'm in 6th grade, and
Wow.
I was wondering if there are going to be more chances to learn more about the waste production and what more people are doing around the world to combat this.
There are lots of people around the world combating waste. Yeah, you want to learn about it in school? Is that your question?
Yeah, kind of.
Yeah. What school are you at?
Lincoln Middle School.
Lincoln Middle School. You can ask your teacher. Ask your teachers about where you want to learn more about that, and maybe there's a lot of people in the San Francisco Bay Area that could come and talk to your school about that. There's a lot of zero waste efforts. Right this weekend, I think there's a zero waste youth conference that's virtual. So there's local folks. I know folks in the city of Alameda, that's Community Action for Sustainable Alameda, does a lot of zero waste stuff. So there's lots of resources to have people come. And now actually, anybody can come in on Zoom, so we can get international experts come and talk too. If you want to get in touch with me, Kylie, I can work with your teachers to figure out local resources to get to your school.
Thank you.
Sure. Anyone else? That's you in the chat, right, Giovanni? Okay, cool. Yes. If any of you want to reach me, it's ann@annblake.com. And or you can contact Lena and I can send you more. My website's a bit of a stub at the moment because I haven't quite decided what I want to do when I grow up. Thank you. Thank you, Lena. Or you can reach me on LinkedIn. I think Lena found me on 500 Women Scientists. Is that right? And that's a relatively new group that I think has happened during the pandemic too. Is how do we take action collectively and get the voices of more diverse scientists up into the world? Mateus, so you have your hand up.
So I was interested in just the idea of the waste like from our schools, because I know the liquid when we're doing, and I haven't really done that much research into it, into how much waste our school produces, but I'll be curious in learning and like just how we could reduce a lot of the waste that we
Sure.
What was it? It was annblake.com.
Yeah. And there's another group, actually, Kylie, this is true for you too. The places starting in your school is perfect because it's really schools. There's a lot of resources for schools to change what they can do. Most of the waste comes from your cafeteria or your food service. And I know in the pandemic, they're probably still packaging meals for you, right? And if you're back in school and when you go back to school, all of that stuff will come. And so there's a lot of single-use plastic there in the production of food. So that's a good place to start. And right here in Oakland, my colleagues at Center for Environmental Health have a lot of resources on safer alternatives for food packaging. You have a lot of food waste. Yes, I can imagine. So there's a bunch of stuff you could do. I don't know about your schools. You could start a composting program. You could talk to the administration about a composting program. You can eliminate some of the plastic packaging in your food. Have fresher food options if you don't already have those. There's another group called Healthcare Without Harm that's working with hospitals to do the same thing, to bring food in from local farms and organic farms. So again, solving a climate problem and a waste problem at the same time. Clean Water Action has something called Rethink Disposable, where you could work with local restaurants. Restaurants are having a hard time right now with pandemic, and I know with DoorDash and all those other things that they're packaging stuff in recyclable, or unfortunately not recyclable packaging. So we can work with schools as this eases up a little bit. Schools and restaurants and other places that buy a lot of equipment with food. There's a lot of plastic there that we can, and then, switching to compostables, which sometimes have toxic materials in them. So one of the issues San Francisco has had, for example, is that they've encouraged compostable materials in various industries, and then they take that stuff back and they sell it as an organic fertilizer, right? And it turns out to have toxic chemicals in it. So the city's been really motivated to try and get those toxic chemicals out of the stuff they sell as organic compost. Mateus, did I get your question? The stuff you can do with your school?
Oh yeah, thank
Great.
you so much.
Sure. I hope I'm pronouncing your name right. All right. Vivek, Spencer, Amelia, and Paige. Thanks, Mateus.
I don't really have a question, but
Paige has a face.
Yeah. I don't really have a question, but I just wanted to say thank you.
Oh, my pleasure.
Interesting presentation.
Always glad to have folks excited by it, because as you can tell, I could talk about this stuff for ages. So it makes me very excited. All righty. So this is the end of, we finished earlier this time, Lena. Last time I was obviously talking too much. Anything else you want to hear about? Because I covered a lot of territory very quickly.
I also want to know, how do non-regulated things get on the shelves? Like,
because mostly historically, and industry has pushed back and say our stuff is safe. We don't need to have it regulated. For some reason, household cleaning products kind of fell in between two different agencies. That's part of it, is that it's the way the regulations are. And there's also, when people push for regulation, we have ideas of things that come into our mouths. So food and drugs are the things that could harm us the most. That's our perception, even though that may or may not be true. So that's how we set up the regulation, right? And then things that kind of go on around us, which is why it's taken us so long to get to indoor air quality. We don't think about that. So it's, it's like I said in response to another question, it's what drives government? It's the people that elect the government, and we tell them what we think is important to regulate. So slowly we've come around and said, you need to regulate these things too. Like children's car seats, right? They had to be safe. Seat belts, each one of these things has been a battle against an industry that didn't want to do it because it cost too much or cost more than they wanted to spend. But, those are people in industry too, and those people have kids and you want them to be safe in cars. So there's there's ways of working to get regulation in when it seems to have fallen through the cracks. And sometimes things are in regulation and people just don't enforce it. So theoretically, the Consumer Product Safety Commission was supposed to regulate chemical things. A subcategory of cleaning chemicals meet the definition of pesticide, so that was regulated by somebody else. So there's all these structural reasons, which is not an excuse for not doing it better, Lena. And that's your question. It's just historically that's how it was set up. Until we realized, and then we get more science and we realized that these things actually were harmful. Who thought a cleaning chemical could be harmful? Turns out they can be. Or if you add like preservative to a product, in that quantity in one product, it's probably not bad. But if you have it in all your cleaning chemicals, all your cosmetics, in your fragrances, I don't know why we need fragrances anyway, to spray into the air to smell better, you could just open a window. In some cases you can't because you're next to an industrial facility, but you get my point. Where else can you fix this, right? And so what we were finding is that different industries were putting the same preservative into a whole bunch of chemicals, and it wasn't until we started seeing health impacts on people that we said, oh, this is a problem, and then you go back and try and fix the problem at the beginning. And then industry had to come up with a new preservative. Sorry, it's a long rabbit hole. Giovanni, go ahead.
Yeah, I wanted to ask, is there a certain element of I wouldn't say anti-capitalism because that kind of implies something political, but like sort of like a fundamental skepticism for capitalism in your work, or do you think it's like more about regulation or gradualism?
Oh, wow. That is I have gone both ways. I think I've spent a lot of time on the incremental stuff and I've sort of lost patience with it. But a lot of folks still work there and think there's options. You can work in the system or you can work to break the system. And I'm kind of in the break the system mode at this point because it ain't working. I mean, the system was built to do exactly what it's doing, right? So if we want to change the outcome, we need to change the system. And capitalism and all that goes with it is pretty, there is a whole effort, conscious capitalism, the benefit corporation world that believe they can make capitalism better. And I'm I could be totally wrong. They can keep doing that and that'd be fine. I think there's some fundamental flaws in the capitalist model, but that's just me. So, and I do have company. I think I have quite a bit of company.